The question is, solve for x to satisfy the equation square root of x plus 1 minus 4 square root of x minus 3, this is one term, plus square root of x plus 6 minus 6 multiplied by square root of x minus 3, this is another term, and the sum of these two terms is equal to 1. Now this is the question. We are writing it down again. Let us call it equation 1. In this, we notice that in both the terms on the left hand side, square root of x minus 3 is occurring. Let us simplify this by substituting a value of y is equal to square root of x minus 3, so that the middle or the nested square root term becomes a non-square root term. Let us then substitute y for x minus 3 root over, let us call it equation 2. That gives the value of y square is equal to x minus 3, or x is equal to y squared plus 3. Then equation 1 becomes, that is, this equation becomes, in place of x we are putting y cube plus 1 minus 4y in place of this is equal to, plus, similarly in place of x we are putting y square plus 3, 6 appears as it is, and then minus 6y, and that is equal to 1. Rearranging terms under both square roots, we get y square minus 4y plus y plus y square minus 6y plus 9 is equal to 1. Now these two square root terms, we recognize them as the squares of y minus 2 whole square, that is the first term, and the second term is y minus 3 whole square. Therefore, square root of y minus 2 whole square plus square root of y minus 3 whole square is equal to 1. So, because there is square inside and square root outside, we can take the square root, and the answer is magnitude of y minus 2 plus magnitude of y minus 3 is equal. Note that the magnitudes or the absolute values of y minus 2 and y minus 3 are taken while taking the square roots of y minus 2 whole square and y minus 3 whole squared. This is because the basic definition of square root function is such that it always returns positive values. For example, even though plus 2 squared and minus 2 squared are both equal to 4, the square root of 4 always returns plus 2, not minus 2. Please check this using a calculator to convince yourself. Also, if positive and negative values are allowed, square root would no longer be called a function, because functions must assign one output to each input. Before going any further, I will request you to please like, subscribe, share, and press the bell icon so that you can get immediate notification when my new problems are uploaded. Now coming back to the problem, we had found out that magnitude of y minus 2 plus magnitude of y minus 3 is equal to 1. Let us examine this for three different reasons. Let us call them case 1, case 2 and case 3, where case 1 is when y is less than 2, case 2 is when y is in between 2 and 3, but y can also be equal to 2. And the third case is when y is greater than or equal to 3. Let us see what happens in case 1. In case 1, y is greater than 2. Y is less than 2. So in this region, both y minus 2 and y minus 3 are negative. Therefore, the absolute value of y minus 2 is equal to negative of y minus 2, and absolute value of y minus 3 is also equal to negative of y minus 3. So when you add both these terms together and equate that to 1, we get 2 minus y plus 3 is equal to 1, or 2y is equal to 4, or y is equal to 2. Now we started this case with the condition that y is less than 2 and arrived at the conclusion that y is equal to 2. This is absurd, and this means that there are no solutions for y which is less than 2. Since x is equal to y square plus 3, that is from equation 3, we conclude that there are no solutions to the equation for x less than 7. Case 2, 2 greater than equal to y less than 3. In this range, y minus 2 is not negative and y minus 3 is negative. Therefore, absolute value of y minus 2 is same, that is y minus 2, but absolute value of y minus 3 is equal to 3 minus y. Putting these values into equation 4, that is magnitude of y minus 2 plus magnitude of y minus 3 becomes y minus 2 plus 3 minus y is equal to 1. On the left hand side, y and y cancel, plus 3 and minus 2 become 1. So therefore we get 1 is equal to 1. Obviously, this equation is satisfied. In other words, irrespective of whatever value is taken for y in this range, left hand side of the equation will always match the right hand side of the equation, because the y terms will cancel and 3 minus 2 will always be equal to 1 on the left hand side. The range is y greater than equal to, the range is 2 greater than equal to y less than 3. Therefore, if you square 4 greater than equal to y square less than 9, or if you add 3, we get 7 greater than equal to y square plus 3 less than 12, So y square plus 3 being equal to x, we can write 7 greater than equal to x less than 12, since x is equal to y square plus 3 from equation 1. So in this range, between 7 and 12, the value of x is a solution to equation 1. Notice that this range is closed on the left hand side, but it is open on the right hand side. That means x can be equal to 7, but x cannot be equal to 12. So in this range, x is equal to, if x falls in this range, then it is a solution to equation 1. Case 3, that is y is greater than equal to 3. In this range, y minus 2 is positive and y minus 3 is not negative. So the magnitude of y minus 2 is equal to y minus 2, and the magnitude of y minus 3 is equal to y minus 3. Then equation magnitude of y minus 2 plus magnitude of y minus 3 equal to 1 becomes y minus 2 plus y minus 3 is equal to 1, or 2y is equal to 6, or y is equal to 3. Thus, y is equal to 3 is the only solution in the range y greater than equal to 3. Since x is equal to y square plus 3 from equation 3, we get x is equal to 9 plus 3, that is 12. So x is equal to 12 is a solution to the original equation 1. In case 2, we had found that every value of x in the interval of 7 to 12 is a solution to the equation 1. Now we add another value of x is equal to 12 as a solution to make the interval closed at both ends. That is, 7 to 12 is closed at both ends. Earlier it was open at the higher end. So the answer is all values of x from 7 to 12, both inclusive, are solution to the equation square root of x plus 1 minus 4 square root of x minus 3 plus square root of x plus 6 minus 6 square root of x minus 3 is equal to 1. Now, if we plot this using a graphic calculator, we get this kind of graphs. This first part, square root of x plus 1 minus 4 square root of minus 3, that is the blue color graph, it is this. Now it starts at x is equal to 3, becomes 0 at x is equal to 7, then it goes on increasing. And the second part, that is x plus 6 minus 6 square root of x minus 3, everything square root is taken, that is the green color graph, and that is this graph. It also starts at x is equal to 3 on the left hand side, goes on decreasing and becomes 0 at 12, and after that it goes on increasing. If you add these two graphs together, we get the third graph, which is red colored, that is this graph, and that represents the two terms on the left hand side of the original equation. And if you examine the graph, you find that this graph also starts at x is equal to 3 at the left hand side. It becomes 1 at x is equal to 7. Then it remains 1 throughout until it reaches x is equal to 12, and thereafter it goes on increasing. There are three interesting facts about the three graphs. One is all of them start at x is equal to 3. That is because of the term x minus 3 square root. X cannot be less than 3, otherwise the whole thing will become complex. Second interesting fact is one graph becomes 1 at x is equal to 7. Another graph becomes 1 at x is equal to 12. And at the same time, at x is equal to 7, the other graph becomes 0. And at x is equal to 12, the previous graph becomes 0. So their sum at x is equal to 7 and x is equal to 12 remain 1. And in between 7 and 12, one graph keeps on decreasing, another graph keeps on increasing, but they do that in such a manner that their sum always equals to 1. So this is a very interesting phenomenon.